Okay, good afternoon to one and all. In the previous lectures, we covered the thermodynamic equilibrium. Then we have seen just started the definition of the concept of thermodynamic process, right? And we have noted the definition of thermodynamic process also, right? Now next is, you can give the heading cycle. Next will be cycle. Thermodynamic cycle. Am I audible clearly?
Yes, sir.
Yes, sir.
Okay. Thermodynamic cycle. So process we have seen. What is the process? Anyone? Anyone can define process? Say, I want to say this 1A2 is the process. What it means? How you can define? That's a statement कसं लिहिता येईल आपल्या प्रोसेस मध्ये? Who will define process? वाचा दिलेले स्टेटमेंट वाचा चला. For not able to recall, you just read it.
A process is said to be occurs when system undergoes the change of state.
Yes, see there. If you see the graph here, can you see the graph on the screen?
Yes, sir.
Yes, sir.
So this 1A2 is the process. So you can say there are number of intermediate states are there in between this state point 1 and 2. So when system undergoes change of states, when system undergoes a change of states, then the process will be occurred, or you can say it is known as process. When system undergo change of state is nothing but process, right? So once you clear with the process, we have to understand now cycle. Give the heading as a thermodynamic cycle. So how you can define thermodynamic cycle? So this 1A2 and 2B1, this complete or this execute a cycle, or this completes a cycle. Cycle आपल्याला कसं definition लिहिता येईल? Anyone? Anyone can define? Can anyone can define? Anyone? So what? Let it be wrong. कसं define करता है cycle आपल्याला? Fast. So कुठे काय फरक पडणार?
A series of events bring repeated many times.
Correct. The series of events brings or get repeats many times. Okay, that is the or it will come to its original state, no? 1 second. Huh? Okay, sorry for inconvenience. So we are discussing about the cycle, the definition of the cycle. So this cycle means what? There are number of events occurring repetitively. Okay. So means the system is starting from one, again coming to point number two, then again is going back to original state. So this will execute a cycle. So you can say in the form of statement like this: number of processes in sequence, number of processes in sequence bring back the system to its original state, bring back the system to its original state, then the system will execute a cycle, then system will execute a cycle. Okay, so this is a definition of the cycle, you can say. Now if you want to have the number of such applications like auto cycle, digital cycle, joule cycle, you might have studied or you might have heard this Joule cycle, Carnot cycle, Breton cycle, or auto cycle, digital cycle. So there are different cycles because in that cycle, uh, who is making microphone kuni on केलंय? In between I'm getting disturbance. So number of processes that will occurs in the logically, in sequentially, and it will again will come back to its original condition or original state, then we can say the cycle is executed there, right? So there are number of processes like or the cycles like auto cycle, digital cycle. Those cycles consist of different processes, maybe constant pressure, constant temperature, expansion process, compression process, and that will complete a cycle. म्हणजे अशा 1 to 2 एक वेगळी प्रोसेस आहे, नंतर 2 to 3 वेगळी प्रोसेस आहे, परत 3 to 4 वेगळी प्रोसेस आहे, and then 4 to 1 ही वेगळी प्रोसेस आहे, पण finally it will complete a cycle, right? So here you need to understand what is cycle, when cycle will get executed. Okay, if you are clear with the definition, the further numerical part or the analysis part will become easy. Okay, note down definition. Cycle: number of processes in sequence, number of processes in sequence bring back the system, number of processes in sequence bring back the system, number of processes in sequence bring back the system to its original state, then system executes a cycle, or cyclic process, cycle or cyclic process. हा ग्राफ काढा समोर दिसतो तुम्हाला तो. Show this graph. Just I mentioned different auto cycle, digital cycle. So those cycle also will draw it for your understanding. Show these two additional graph also to understand the cycle. On y-axis pressure, x-axis volume. We can show the state points. One, two, three, and 4. This is 1, 2, 3, and 4. Here we can say PV equal to constant. PV is equal to constant. याच्या खाली म्हटल्यास रिप्रेझेंटेशन ऑफ ऑटो सायकल. रिप्रेझेंटेशन ऑफ ऑटो सायकल O capital. Representation of Otto cycle. So Otto is the name of scientist. This is a representation of Joule cycle. Joule's cycle. Representation of Otto cycle and Joule cycle. In this Otto cycle and Joule cycle, you can find 1 to 2 is the constant temperature process. 2 to 3 heat additional constant volume. 3 to 4 expansion with temperature constant. 4 to 1 heat rejection. So there are different processes, but they follows one logical sequence and then again coming back to its original state. So that will exhibit a cycle. Okay, drawn?
Yes, sir.
Okay. तर सर्वांना कळालं असं सायकल कसं असते की ज्यामध्ये वेगळ्या प्रोसेसेस असतात. आता जर तुम्ही ग्राफ पहिला बघितला तर त्याच्यामध्ये 1 to 2 इज द वन प्रोसेस और 1A 2 इज द प्रोसेस. किंवा इकडे तुम्ही सेकंड ग्राफ मध्ये बघितलं 1 to 2, 2 to 3, 3 to 4 ऑल आर द प्रोसेसेस. System is changing from one state to another state, so that will execute a process. Okay, अशा सगळ्या प्रोसेस ज्या कंबाईन केली तर काय होते आपल्याला सायकल तयार होत असते. राईट. So now we will understand the one important process, that is the quasistatic process and non-quasistatic process. You can give the heading. Erase करू का diagram graphs?
Yes, sir.
Okay.
Yes, sir.
We'll move to the next. Give the heading. Quasistatic and non-quasistatic processes. Give the heading. Quasistatic and non-quasistatic processes. Okay, I will draw one simple diagram. You can draw it. किंवा हे जरी साइड हे जे दाखवले हे जरी काढले तरी चालते. It is option to you all. समोर स्लाइड मध्ये दिसतात त्या डायग्राम काढल्या तरी चालतात. नसेल तर दुसरी डायग्राम काढून दाखवतो. You can draw this diagram also, no problem. किंवा ही डायग्राम काढून चालले. तर मी नोट्स मध्ये ही डायग्राम काढून दिली तेव्हा मी काढून दाखवली तुम्हाला. Can you see this?
Yes, sir.
Okay.
ग्राफ काढायचंय का सर?
ग्राफ पण काढू शकता. ग्राफ पण तुम्हाला थोडस प्रॉपर काढून देतो मी. ग्राफ फक्त असा काढा. Regular hour we draw like this. 1, 2. Okay. These are the equilibrium states.
सर इथे प्रोसेस पाथ अपोजिट साइडला दाखवली आहे.
हे मी जे काढतो का, जे मी काढतोय ना ते काढा. जर तुम्ही हे काढणार असाल कुठलं हे ए आणि बी काढणार असाल किंवा ए आणि बी काढणार असाल तेव्हा त्या केसमध्ये तुम्ही ग्राफ असा काढा किंवा असा काढा, फरक पडत नाही. जर तुम्ही हे कॉम्प्रेशन दाखवणार असेल तर इथं 1 दाखवा लागेल, तर 2 दाखवा लागेल. जर मी काढलेली जर तुम्ही डायग्राम काढायचं असेल तर मग हे 1 to 2 बरोबर आहे. असं एक्सपान्शन होत आहे. तुम्ही कुठली काढली तुम्ही? मी काढली का दुसरी काढली?
तुम्ही काढली सर.
ओके ठीक आहे, हेच काढा. Yes. हे थोडस ब्लॅक शेडेड दाखवा पिस्टन. Over? Is it over?
Yes sir.
Yes, sir.
Okay. Now see, let us understand the meaning of quasistatic process. Quasistatic process means what? It is also called as quasi-equilibrium process. Quasi-equilibrium. So if you see the meaning of quasi means what? What you can understand from the word quasi? What you understand from the quasi word and the static? Static means what? Let us understand first meaning of static. Static म्हणजे काय?
Rest.
Rest, stationary, right? And quasi means what? Almost stationary, almost rest, right? Such type of process is known as quasi-static process, or you can say quasi-equilibrium process. And in such a process only equilibrium can be achieved, equilibrium can be maintained, right? If the process is happening very slow, if the process is happening very slow, in that case only the equilibrium condition will be achieved, or you can say system will be in the thermodynamic equilibrium. जर प्रोसेस हॅपन घडत असताना ती जर एकदम स्लो असेल तरच तिथे इक्विलिब्रियम कंडिशन अचीव होत असताना तर होणार नाही. अशा प्रोसेसेस प्रॅक्टिकली इम्पॉसिबल आहे, लक्षात ठेवा. देर आर नो सच प्रोसेस एक्झिस्ट इन युनिवर्स विच इज एक्झॅक्टली क्वाजिस्टॅटिक प्रोसेस. ओके, आपण जर कॉजीचा अर्थ असा आहे की ते स्टेशनरी नाहीये, पण इट इज एक्झॅक्टली ऑलमोस्ट स्टेशनरी. We have to get the meaning of the quasi-static is what? The process is almost stationary but not exact stationary. So such kind of process is called as quasi-static processes. So if you see the examples, can you tell the examples of quasi-static processes? Practical examples. Have you seen any situation? It looks like quasi, म्हणजे ते असं दिसतंय की ते स्टेशनरी आहे, पण there's some movement, there's some motion. दिसताना स्टेशन वाटते पण ते तसं नाही येते ऍक्च्युअली. एनी एक्झाम्पल? Anybody? Have you seen such process? याच्या अगोदर कुठे बघितले? म्हणजे असं वाटतं की ते एकदम स्टेशनरी आहे, पण ते ऍक्च्युअली स्टेशनरी नाही येते. देयर इज सम मोमेंट, दॅट इज द क्वाजिस्टॅटिक, ऑलमोस्ट स्टेशनरी but not exact stationary.
Cylinder containing gas.
Huh?
Gas cylinder.
Gas cylinder. Okay. Actually, it looks means stationary, but it is moving. Okay. It is a quasi-static process. Azul. In Marathi, one animal you might have seen, that is Google guy. Have you seen?
Yes, sir.
Google guy. बघा ते असं वाटतं की ते जमिनीवरती एकदम स्टेशनरी आहे, पण त्याच ते पुढं रेसिप्रोकेट होत असते ना, पुढं मूव्ह होत असतं ते, पण ते दिसायला कसं दिसते आपल्याला ते स्टेशनरी आहे का. सो दॅट इज व्हॉट दी बेस्ट एक्झाम्पल ऑफ ए क्वाजिस्टॅटिक प्रोसेस. म्हणजे ज्यावेळेस तुम्ही थर्मोडायनामिक अनालिसिस करता, प्रोसेसचा स्टडी करता, if you want to make some conclusions, if you want to do the detail analysis as an engineer, okay, so process must be made very slow, process must be made very slow, then and then only you can carry out the experiment and you can get the desired observations, you can get the desired observations, desired readings, right? तर त्यासाठी काय केले पाहिजे, प्रोसेस पूर्णपणे आपण स्लो केली पाहिजे, आणि स्लो केली तरच ज्यावेळेस प्रोसेस कॅरी आउट कराल त्यावेळेस इक्विलिब्रियम कंडिशन्स प्रत्येक ठिकाणी प्रत्येक स्टेटला अचीव होतील, आणि यू कॅन गेट द रिक्वायर्ड रिझल्ट्स, यू कॅन गेट द डिझायर्ड रिझल्ट्स, accurate results. Okay, that is why if the process proceeds in a such a manner that system remains infinitesimally close to equilibrium state at all the times, such processes are known as quasi-static processes or quasi-equilibrium processes. ज्यावेळेस प्रोसेस ती घडत असते ती अशी इतकी स्लो होत असते की आपल्याला वाटते की ती स्टेशनरी आहे असं. ओके, जर असं घडत असेल तर प्रत्येक स्टेटला ती काय इक्विलिब्रियम कंडिशन त्या ठिकाणी अचीव होत असते, और ऍटलीस्ट इट विल ट्राय टू मेंटेन द इक्विलिब्रियम. म्हणून बघा हा जो ग्राफ तुम्हाला दिसतोय, हा ग्राफ तुम्हाला समजून घ्यायचंय. बघा आता या ग्राफ कडे जर बघितलं तर काय दिसतंय, एक्सपान्शन दिसतंय, बरोबर आहे का? हॅलो, can you see the graph? 1 to 2 is the what? Is it expansion or compression? एक्सपान्शन. बघा आता इथं आपण म्हणून एक्झाम्पल घेतलेलं आहे. पिस्टन इज फिल्ड विथ गॅस अँड ओव्हर द पिस्टन द वेट इज प्लेस्ड. म्हणजे 1 kg 2 kg 3 kg अशी वेट प्लेस केलेली आहे. आणि वरती काय स्टॉपर आहे. वरती काय ते स्टॉपर आहे. म्हणजे तिथपर्यंतच ते पिस्टन जाऊन थांबेल, त्याच्या पुढे जाणार नाही. राईट. थोडक्यात पिस्टनचं हेड म्हणून आपण देतो, त्याच्यापर्यंत पिस्टन जाणार आणि थांबणार. So we have to carry out this quasistatic process. How to proceed? As the gas is filled in the cylinder, it consists of or you can say as a system, right? Now we'll keep on removing the weights step by step, half kg, 1 kg, half kg, 250 kg. Like this, if you keep on removing the weights, what will happen? What will happen? जर तुम्ही एक अर्धा केजी, हाफ केजी, एक केजी असं वेट जर काढत चालला तर काय होईल? कुठली प्रोसेस कॅरी आउट होईल? एक्सपान्शन का कॉम्प्रेशन? पिस्टन मध्ये एक्सपान्शन विल टेक्स प्लेस, राईट. मीन्स इनिशियली इफ यू नोट द प्रॉपर्टीज, प्रेशर, व्हॉल्यूम, टेम्परेचर, वॉट एव्हर इट इज, ओके, इनिशियली, and if you keep on removing the weights slowly and slowly, so the process will take place very slow and expansion will be carried out. Okay, and during this expansion process all the states will come in a equilibrium conditions. All the states will reach a equilibrium conditions, right? So this is what the quasi equilibrium process or quasi static process. So process proceeds in a such a manner that system remains infinitesimally close to equilibrium state at all the time. म्हणून बघा, एका स्टेट पासून दुसऱ्याकडे स्टेट जात असताना ज्या इंटरमिडिएट स्टेट्स आहेत, त्या मधल्या जे स्टेट्स आहेत त्या ठिकाणी पण इक्विलिब्रियम कंडिशन अचीव होते, किंवा द सिस्टम इज ट्राइंग टू मेंटेन द इक्विलिब्रियम कंडिशन. सो सच अ प्रोसेस इज नोन एज quasi equilibrium process or quasistatic process. आता हे झालं एक्सपान्शन प्रोसेस. जर तुम्हाला कॉम्प्रेशन ना तुम्हाला हा कन्सेप्ट एक्सप्लेन करायचा असेल quasistatic, नो प्रॉब्लेम. So you can compress or you can press, apply the force on the piston will move towards left, so the compression of the gas will takes place. It will happen very slowly, okay, and every time it will try to maintain the equilibrium conditions. If it maintains equilibrium condition, that means it is known as quasi equilibrium condition or quasi equilibrium process. Okay, so this is the quasistatic. But practically, is it possible to achieve this much slow process? Is it possible? No. That's why maximum processes are non-quasistatic process. They proceed very fast. They proceed very rapid. Okay, that is why there is no process exists in the universe which is quasistatic process. But for our purpose, for our study purpose, the engineers wants to make some analysis. We have to make the process, or we have to make the process very slow, and then we can carry out our experimentation. To carry out our experimentation to get the desired results. Right? So I hope you are clear with this. Write down. When process proceeds, quasistatic process. When process proceeds in a such a manner that the system remains
Can you repeat?
when process proceeds in a such a manner that system remains infinitesimally infinitesimally close to an equilibrium state.
Repeat it, sir.
Repeat. Okay. When process proceeds in a such a manner that system remains infinitesimally INFI NITE SIMALLY infinitesimally close to an equilibrium state, close to an equilibrium state at all the times, at all the times, at all the times.
इक्विलिब्रियमच्या पुढे काय सर?
इक्विलिब्रियम स्टेट्स STATE या मधल्या जे स्टेट्स असतात ना, ह्या पण इक्विलिब्रियम स्टेट्स आहेत, लक्षात ठेवा. इक्विलिब्रियम स्टेट्स at all the time, at all the time is known as quasistatic process, quasistatic process or quasi equilibrium process, or quasi equilibrium process. Next line, infinite slowness, infinite slowness, INFINIT, infinite slowness is the characteristic feature, infinite slowness is the characteristic feature, character spelling CHARACTERISTIC. Hello,
Repeat करा sir.
characteristic feature. I will repeat the spelling of characteristic. CHARACTERISTIC, characteristic, characteristic feature, characteristic feature of quasistatic process, quasistatic process, quasistatic process. आता आपल्या एक्झाम्पल नुसार आपल्याला समजून घ्यायचं क्वाजिस्टॅटिक. तर आपण ते जे एक्झाम्पल दिलेलं आहे पिस्टन अँड सिलेंडरचा, की ज्यामध्ये गॅस फिलअप केलेला आहे, स्टेप बाय स्टेप आपण वेट्स रिमूव्ह करत चाललेलो आहे आणि मग एक्सपान्शन कॅरी आउट झालं. मग एक्सपान्शन कॅरी आउट असताना एकदम स्लोली आपण कॅरी आउट करतोय, राईट. त्यात कुठल्याही प्रकारचा जर्क बसत नाही. जर्क बसला का म्हणायचं की सिस्टम विल नॉट मेंटेन इक्विलिब्रियम कंडिशन. इतकं स्लोली आपण ते एक्सपान्शन कॅरी आउट करतोय. दॅट इज वाय इक्विलिब्रियम कंडिशन्स आर मेंटेन at every time, at all the time. ठीक है, write down. Let us consider frictionless piston and cylinder. Let us consider frictionless piston and cylinder, frictionless piston and cylinder, piston and cylinder, comma, the gas is filled in the cylinder, the gas is filled in the cylinder, the gas is filled in the cylinder, and the properties are measured, the properties are measured at the start, the properties are measured at the start of the process, are measured at the start of the process. Full stop. As weight is removed, step by step, as weight is removed step by step, the expansion of gas, the expansion of gas takes place, the expansion of gas takes place, and piston moves upward, piston moves upward till it hits HITS, till it hits the stopper, till it hits the stopper. स्टॉपर पर्यंत जाईपर्यंत ते एक्सपान्शन कॅरी होत जाणार, लक्षात ठेवा. till it hits the stopper of the cylinder, stopper of the cylinder, and properties are measured, the properties are measured. Full stop. This process happens very slow. This process happens very slow. This process happens very slow, comma, when system passing through.
रिपीट करा.
This process happens very slow. This process happens very slow, comma, when system passing through, when piston, sorry, काय लिहिलं? This process happens very slow when system passes through, when system passes through, when system passes through all the equilibrium states. System passes through all the equilibrium states, all the equilibrium states, and proceeds in a reverse direction, 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 and proceeds reverse direction. म्हणजे एक्सपान्शन होते ना, वरती चाललं ना ते, रिव्हर्स डिरेक्शन झालं ना ते, and proceeds in a reverse direction. Hence it is called as reversible process. 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 Next line. In quasistatic process, all the states are in equilibrium. In quasistatic process, all the states are in a equilibrium. In quasistatic process, all the states are in a equilibrium. Okay.
Yes, sir.
परीक्षेत जर प्रश्न विचारला, एक्सप्लेन quasistatic process or quasi equilibrium process, मग काय येणार आन्सर? त्याचा पहिला तुम्ही डायग्राम काढा, ग्राफ काढा, आणि त्यानंतर मग त्याचे डेफिनेशन आणि जे एक्सप्लेनेशन आता दिले मी तुम्हाला, तेवढं जर लिहिले तर यू विल गेट फुल मार्क्स, 3 out of 3. ठीक आहे. So we'll stop for the today. Give the attendance. Roll number 1.
Present, sir.
2.
Present, sir.
3. Roll number 3. 4.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7. 8.
Present, sir.
9.
Sir.
10. Roll number 10. 11.
Present, sir.
12. 13.
Present, sir.
14.
Present, sir.
15. Roll number 15. 16.
Present, sir.
17.
Present, sir.
18. Roll number 18. 19, 19, 20,
Present, sir.
21,
Present, sir.
22, 20, 23, 23, 24,
Present, sir.
25, 26, 26, 27,
Present,
28,
present, sir.
29,
Present, sir.
30, 31, 31, 32, 32 is there,
Present, sir.
33, 33, 34, 34, 35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present,
40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43, 43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56,
Present.
57,
Present, sir.
58,
Present, sir.
59, 59. Okay, मैं absent number read करतो once again. Roll number 3, 7, 10, 12, 15.
Present, sir.
Number.
12.
Okay, 15, 18, 19, 26, 31.
26 present, sir.
Okay, 31, 33, 59. These are absent. Okay, thank you very much. We'll conclude meeting here.